Alright, so we said this semester we're going to deal with two types of potential energy, and the first one we'll talk about is gravitational potential energy. So we happen to live in a constant gravitational field which points downward. It has a magnitude of 9.8 meters per second squared. And so in which direction was the gravitational force pull on a mass? Well, obviously it wants to pull the mass downward. So if I have an object that starts at a certain height and I let it fall, well, clearly what's happening is that the gravitational force is doing positive work on that object. If, on the other hand, I start with an object at a lower height and raise it up, because now the gravitational force points opposite the direction of the displacement, the gravitational force does negative work. So here, gravitational force points down, displacement points down, gravitational force does positive work. Here, gravitational force still points down, but the object is moved up, so the displacement points in the opposite direction, so the gravitational force does negative work. Well, what this means then, because the gravitational potential energy is related to negative the work done by the gravitational force, so what this means is that I increase the gravitational potential energy when my mass moves up. So you increase the potential energy by making the gravitational force do negative work. That happens when my mass moves up. I decrease the gravitational potential energy when I allow the gravitational force to do positive work. So when the work done by the gravitational force is positive, i.e. the mass moves down, then you decrease the gravitational potential energy. If you move the mass horizontally so that it stays at the same height, then you're not doing anything to change the gravitational potential energy. It stays with what value it has. So conceptually, it's very easy for me to think about whether I'm increasing or decreasing the potential energy simply by thinking about whether I'm raising or lowering my mass. Okay? So when we did the calculation, when we calculated the work done by the gravitational force, we said, oh, that's equal to negative mg delta y. And again, this delta y was the vertical displacement, and delta y was positive when our object went up and negative when our object went down. Well, since the change in the gravitational potential energy is just negative the work done, well, that's just going to cancel out that minus sign, and so I get the change in the potential energy is mg delta y. And again, mass is positive, g is always positive, and delta y is positive when my object moves up and negative when my object moves down, which means that I increase the potential energy when my mass moves up. Positive, positive, positive. So that checks. I decrease the gravitational potential energy when my mass moves down. Positive mass, positive g, negative delta y says that I have a decreasing potential energy. So that checks out. And then again, if my mass remains at the same height, then delta y is 0. So sure enough, my change in the potential energy is 0. So this equation works out. Again, one of the things we talked about when we talked about calculating the work done by the gravitational force is we're sort of embedding something that has a direction, positive or negative, inside a scalar quantity. And so it's often easier just to say, well, let me define three positive things, right? Mass, magnitude of the gravitational acceleration, and then this positive distance that my object moves up or down, and then I'll take care of the plus or minus sign. And so we're going to do exactly the same thing for the gravitational potential energy. We're going to say it's the change in the gravitational potential energy is just going to be plus or minus mg delta h, where again mass is positive, g is positive, delta h is positive. It's just the positive distance that you move vertically, either up or down. And then we're going to use the plus sign when we move up, the minus sign when we move down. So we've sort of built in kind of our definitions here that say that if our mass moves up, we're going to use the positive sign. If our mass moves down, we're going to use the negative sign. And if our mass remains at the same height, then again, delta H is 0. So our change in gravitational potential energy is 0. Now, if you want to talk about the gravitational potential energy, well, really what that is it's shorthand for saying the gravitational potential energy relative to the point where the gravitational potential energy equals 0. So you can understand why we never say that entire phrase. But we need to keep in mind that that's what we always mean. which means that if you want to talk about the gravitational potential energy of your object at some point, you have to have a 0 point that you're really talking about in reference to. For our constant gravitational field, we're basically going to pick any height you want to make the gravitational potential energy equal 0. So what we'll often do within a problem is we'll often pick, say, the lowest point within the problem. We don't have to, but it's often a choice that we make. And then we can define the gravitational potential energy at any point by this equation. So plus or minus mgh, where again, this is just our positive mass. This again is our positive magnitude of the gravitational field. And then this is the distance above or below the 0 point. So here I have an object that's above the 0 point, so it would have a positive gravitational potential energy. So it would be plus mgh. If I let it fall, so now its final point, so it started with positive potential energy, it fell to 0 potential energy. So again, that's still decreasing because I'm going from final minus initial, 0 minus something positive. This mass, on the other hand, starts with 0, and then if I let it move up, well, now it has a final potential energy that's positive, so again, its change in potential energy is going to be a positive value minus 0. For either of these, if I'd let this mass fall even farther, then it would have been below the 0 point, and so it would have ended up with a negative gravitational potential energy. And again, if you don't like that, fine, you can just redefine where your 0 point is to put it into a different place so that you don't deal with that negative value. But as a general rule, we're just going to pick a point for the gravitational potential energy equals 0, and then anything above it will have positive potential energy, anything below it will have negative potential energy, anything on that line will have 0 gravitational potential energy, and then we'll just use this equation to calculate how much based on how high it is above or below the 0 point.